Lesson 11-8, Rational Equations. Our objective is to solve rational equations and use rational equations to solve problems. Our standard is Algebra 1 7.2. Equation with an equal sign means you're going to solve for the variable. So what does the variable equal? So basically you can start off with something that we have already done before. This was something we did in pre-algebra. A rational equation could look just like a proportion, and we've definitely done that. So this first example is showing you something that is called rational equation, but something we've already done. So example A is 8 over x plus 3 equals 2 over x minus 6. So if you get a rational equation like this, basically what you're going to do is do the cross-cross, and you're going to distribute and take 8 times the quantity 8x minus 6, so 8 times the quantity x minus 6, and that would be equal to 2 times the quantity x plus 3. So I would go ahead and distribute both sides, because that's how you solve any multi-step equation. So you'd have 8x minus 48 equaling 2x plus 6. What's my next step? Subtract the x term. Which one am I going to go with? Right, the 2x is smaller, so subtract 2x from both sides. I get 6x minus 48 equals 6. And now what? Add 48. And I'm running out of room, but 6x equals 54. Divide both sides by 6. X equals 9. So we have solved for the variable x, and x equals 9. All right, questions about that? All right, the next problems are probably more what you might think of, a little more difficult, a few more steps, but it's very similar to something that we did early on when we said kill the fraction. Does anybody remember what we did when we killed the fraction? Josh? Not multiply by the reciprocal, but we did multiply by something. Ben?
Denominator.
Just a denominator?
Well, the fraction's denominator.
Just one of the fractions denominator?
Well, for that fraction,
Well, what if there was 3 or 4 different fractions?
then you would multiply it by, I don't know,
Multiply it by, what do we multiply by, Megan? Least common denominator. Multiply by least common denominator. So what we would do, if there was multiple fractions in the problem, we'd find the common denominator and then multiply the whole problem by that common denominator, and that would cause every denominator to fall out. And that's exactly what's going to happen here. Now, some of the denominators here being expressions like that, it can make it kind of complicated. So we've got to decide what would the common denominator would be. This problem, 5 over x plus 1 minus 1 over x equals 2 over x squared plus x. Well, basically the first thing you've got to do before you can go any further is look at all the denominators and see if they can be factored in any way. And x plus 1 can't be factored, and plain old x cannot be factored, but x squared plus x, I can factor that. I can factor out a common factor of x, and that would leave x plus 1. Now, the good news about what just happened there, look at how the denominators are set up. There's an x plus 1, there's an x, and then there's a product of them. So that's very good news. What's my least common denominator then? The x times x plus 1. You've just got to make sure whatever you multiply by contains every one of those denominators, so that when you multiply by it, every one of those denominators falls out. So I'm going to multiply all the way through this problem by x times the quantity x plus 1. And basically you got to think about, yeah, I'm multiplying by that, but it's really over 1, isn't it? You don't have to write the over 1. I'm doing it just so that you can kind of see what happens here. So I'm going to go one step at a time. First, I'm going to take this denominator times 5 over x plus 1. And when I do that, the x plus 1 and the x plus 1 cancel out, right? So what's left to be multiplied? X and 5. So it would be 5x minus, okay, now let me kind of go back over here. Take this back out and write it like this, x plus 1. Minus, all right, I've got 1 over x. So what cancels out this time? The x and the x. So when I multiply this times this, what's 1 times x plus 1? Okay, and I'm going to put that in parentheses because of that negative, x plus 1. That's going to be a little bit of a problem if there's a minus there and you don't be aware of it being a problem. All right, equals. Now, last step, if I take this times the last and the right side, the last term and this on the right side, what cancels out this time? Everything. That whole denominator, that whole numerator, so it equals just 2. Much simpler problem, but we got to be careful of this sign right here. It's minus that whole thing, which in essence changes the signs of everything inside the parentheses. So 5x minus 1 equals 2. And for you guys, this problem should be pretty simple at this point. I've got a 5x minus x together on the left. You need to combine those two for 4x minus 1 equals 2. Add 1 to both sides. 4x equals 3 and divide by 4. So x equals 3/4. Do not change that to a decimal. Leave it 3/4. Questions about that? Okay, now, something really important. It says, with a variable in the denominator, you must check for extraneous solutions. Solutions that cause the denominator to equal 0. And therefore, the answer to be undefined, and it cannot be an answer. So here's the thing. I need to check all of these denominators. So we did this very early on in the chapter. My first rational equation, or part of the rational equation, but rational expression, the denominator is x plus 1. Remember setting it equal to 0 and saying that's what x can't be? So subtract 1. X can't be negative 1. Okay, for the second term, what can x be? 0. And then this one would be the same two answers because they repeat. So if I came up with an answer of negative 1 or 0, I could not say that's the answer. But since x is 3/4, we're fine. It is 3/4. Okay. I probably should have mentioned that back up on the top problem. Let's go back up there really quick. On these two, what two answers can x not be? Can anybody tell me? My tree? Yeah, I couldn't have come up with negative and 3 and 6. That would have been bad. Okay, but it didn't. It came up with 9, so we were okay. So you do have to check if there's variables in the denominator what x cannot be. So let's see what happens here on this last example. 3 over x minus 1 plus 6 minus 9 over x minus 1 equals just 6. So my common denominator, that's great. It's the same. So I'm going to multiply both sides, or everything I should say, by x minus 1. And what happens then when I take that times both of the first two terms? Do you see what happens? Denominator just falls out. That's great. So on the left, I'm left with 3x plus 6x minus 9. On the right, I would take 6 times the quantity x minus 1. So on the left, I get 9x minus 9. On the right, 6x minus 6. All right, let's try to solve. I got a variable on each side, so I'm going to subtract 6x. 3x minus 9 equals negative 6. Add 9. 3x equals 3. Divide by 3, x equals 1. Okay, now, in my original problem, I have variables in the denominator, so I've got to set my denominators equal to 0 to see what bad answers there could be. And if my denominator is x minus 1, I would solve this and say, oh, look at that, x equals 1 would make it 0, and x equals 1 is the answer. So that is called an extraneous solution. Basically means it came out to that, but it cannot possibly be that. So there's no other possible answer, therefore, empty set. There's no solution to this problem. Okay, so if they ask you for extraneous solutions, you'd say that extraneous solution was x equals 1, but to this problem, there is no solution. Olivia. Well, you've always got to check the variables in the denominator and set them equal to 0 and figure out what the answers cannot be.
Could we do that first?
You could do that first. It's got to be done first or last, one or the other. But you still have to go through the steps to solve the problem. And then if there is a conflict, then you just say there's no solution, and that answer would be considered extraneous. It came out to that answer, but it can't be that answer. Are there any other questions?